perched at the ground. Interesting thing to think about. But
Yeah, if you're in the Jefferson airplane, in the smoking section of the Jefferson airplane, that's what you'd want to know
that's
about.
right. We are live and ready to go whenever you are, John.
Okay. Welcome to our weather discussion. We have one more to go next week, and then we will take the summer hiatus unless something gets really interesting, and nothing that interests me will happen over the summer. So if something does get interesting, I'm not giving another one of these till September. So, you know, if you're interested in severe weather or something like that, or hurricanes, you got to step up. It's not going to be me. Okay, so we're looking at our satellite movie amalgam from the last week of the, you know, over the continental 48 and adjacent waters. It's really been an interesting week. There's been storm after storm over the continent. There's been some that have developed off the continent. This one here is one, but not the only one, of really intense developments. It's been quite interesting. I think I've noticed a few things I haven't paid attention to before too, and maybe as I'm saying a few words about some of these elements, watch the Isla de Cuba. You're going to see some really interesting little developments right along the spine of the island at about midnight every day. Boom, there's one of them. And then about 24 hours later, boom, another one. So all these clouds are developing on the peaks of the highest terrain in Cuba, but not every day. And that's the other thing that's interesting. Some days they don't develop, and so I'm wondering what is it in the environment that discourages the development on some days and allows it to proliferate on others. And it doesn't seem like it's a very obvious answer, because there's nothing really on the synoptic scale that presents itself as occurring from one day to the next. There's one really nice day all the way along the Cordillera, all the way through there, second day in a row. And then there's a couple of days where nothing happens. That's a little bit of a puff. I think the next day is one where nothing happens. You know, maybe it's earlier in the sequence. Yeah, we're near the end, so it's earlier in the sequence. So watch one more time. Maybe it's this day right here. I think you go through the whole day, nothing really happens. There's stronger easterly flow, maybe, that has something to do with it. I don't know. But then after that, every day. So that's kind of interesting. But we've had one storm after another. I think, did we have rain on Tuesday? A little bit on Monday night and Tuesday or something? I can't remember. I hate coming in from class and trying to do this and make sense of what I've paid attention to during the week, but it's usually not in our own area. But we got close anyway. We're getting close today. We'll see in the radar that the stuff that develops during the day yesterday and into the evening last night over Kansas, Nebraska is really organizing the flow for the, I think, a pretty interesting upcoming weekend. It's going to rain a little bit tonight, I think. Probably going to rain a little bit tomorrow afternoon, and certainly tomorrow evening and into Sunday. It'll be wild. And it looks also, and I don't want to steal Patrick's thunder, no pun intended, but next week will be a perfect last week of the term, because if you've got to study, which all of you do, that's what you're doing in your lives right now, you won't be distracted by the weather. And hopefully that will be the case through the finals week too. I think it will be through the weekend. So next weekend coming up. Okay, so I'm not going to make any more comments on this. Thank you, Pete, for preparing it. I think in the fall, when I have more time to think about it, I usually have something more to say about it, but it's hard to do in the spring.
The loop is out there all the time, so
Yeah.
that's not just a weather watch thing. It's,
Yeah, no, I do pay attention to it. In fact, that's exactly my point. I pay attention to it on Friday morning in the fall.
Yeah.
I can't do it in the spring. Let's take a look, though, at the 500 millibar movie as a way to kind of
From the Super
sync
Pete?
with that. Yeah, from the Super Pete. Yeah, so you're going to watch the parade of events. Maybe we'll step through, Pete, instead of a movie. So yeah, this is last week. So there's one of the big cold pools that was sitting over us. I think it did rain a little bit longer over the weekend than we expected. It just persisted because it was chilly a lot. But predominantly westerly flow across much of the continent, and that kept it warm to the southwest, chilly to the north over us. Let's go a couple of clicks forward. Big anticyclone over Canada. Why read at the same time? Okay, there we go. And that thing is going to be the progenitor of various disturbances in the northwesterly flow over the archipelago. One of them was really cold. In fact, it might be this first one. It was minus 40 and cold over the central archipelago. And there was some concern that maybe this cold air where is it exactly going to land? I think we were pretty certain it wasn't going to be here, but it got really cold over the northeast part of Canada as the week goes on. You'll see that. And then there's a train of waves making landfall on the Pacific coast, and then trying to ride this ridge, and we'll see what progress they make. So we'll step one at a time. So there's trough one on the west coast. The ridge is extraordinarily amplified all the way up into the the North Slope area. Very cold air. You could tell by this time there's no threat for us, but I would guess southern Quebec was gonna be under the gun for some pretty chilly air. Let's keep going. And no obvious wave, but there's only 4 winds, and so it's hard to know for sure if anything was in between them, but it's still pretty chilly over Hudson Bay. This is wave number 1 that came through southern British Columbia. It looks like it's gonna find a short route to Lake Winnipeg, so it's not gonna have to go over the whole ridge. Let's keep going. Yeah, it kind of carves it out itself, comes through like that. I think we saw that as swirly number 1 over us during the week. This would be into Monday into Tuesday. Here's the minus 42 air over eastern Hudson Bay, and it's nowhere near us, luckily. Keep on going. So there's one of the waves, then another one upstream. Keep on going, Pete, thanks. There's one off the coast. I think we saw one of those developments early in the week. This was the one that kind of came by us on Tuesday, and at least put clouds in the sky. I think it did rain on Tuesday. And then another wave. So that one comes right through. Here's the trough axis. We're downstream of it on Tuesday morning. Really nice. Passes us during the day Tuesday. There's the next one upstream, and we'll feature off the coast. And now we'll go one more click. This was Wednesday, we're kind of, or Thursday, Wednesday night. We're thinking about the weather for the weekend around this time. A couple of questions from my class. Eric had some really good ones at office hours the other day. Nothing's really obvious about what's going to spawn the weather for the weekend on Wednesday. It starts to get a little more obvious on Wednesday night. There's one of the troughs off the coast of California and the Baja. That's a feature. And then there's going to be some others coming out of this complex for the second part of the weekend. So let's keep going forward. So 12Z, this is now last night. So that wave emerges over the Four Corners, begins to develop a cyclone over Kansas and Nebraska. And this wave is still relegated to the prairie provinces, but there's a new one off the coast of Oregon and Washington that might be a factor to watch out for the weekend. And then we go to the next one, which is the current time. And there's our upper trough. Cyclone is over Kansas, Nebraska right now. Very strong southerly flow off the western Gulf of Mexico. We'll see in a minute. Dew point gradient is fairly large. We're still relatively low in the dew points, but you don't have to go too far south to really get into the moist air. This wave that had come across the British Columbia coast is going to stay to the north, but it's this feature here that might be a factor for the weekend. And it's got some interesting elements. There's some geostrophic cold advection and cyclonic shear here, and so it probably means this upper feature is going to deepen as it comes across California, southern Arizona, and parts of New Mexico. So it'll get us in a position for something else late in the weekend. This is issue number 1 for the first part of the weekend, including tonight. So let's take a look, if we can, Pete, at the 850 millibar map from the current time. So there's the cyclone that's developed in response to the upper trough that we traced and found it kind of over the central part of the plains. There is 15 degrees with a 0-degree dew point depression at Dallas, so that's really warm, moist air at 850 millibars. We got dew point depressions in the single digits everywhere until you get to Lubbock, then suddenly, wow, unbelievable. So there's a patch of really high water vapor content over eastern Texas, parts of Oklahoma, arguably making its way up to Missouri. But look at right here at, is this Moline? 29-degree dew point depression. And then Green Bay, 20-degree dew point depression. So the boundary is right about with this isotherm between dry air and very much more moist air to the south. And I think when we take a look at the radar reflectivity, you'll see that's about the boundary across which it's been difficult, I should say, this morning for a radar echo to make it across there. It's going to take a while to moisten these really dry columns. Once they do get moistened, it's going to be a really rapid increase in dew point here, and probably an increased threat for thunderstorm activity. Okay, so let's take a look at, just to put it in context, 300 millibars for the current time. Look at this, wow, who would have guessed? Okay, really weak winds associated with this upper trough at the tropopause, near tropopause level. The next feature, which is being carried by these much stronger winds off the northern California coast, is substantially more energetic when viewed from this perspective. This is really weak, so it's maybe mostly a lower tropospheric feature of interest. And I don't know what goes on with the so-called low-level, the Great Plains low-level jet, but we have a much more intense 850 millibar disturbance than we do at 300 millibars, so maybe that'll be a factor in some of the moisture transport, but I'm a non-expert on that. Can't say more. Okay, can we take a look, Pete, at the visible satellite image just for the last several hours here over the continent of the United States? and adjacent water. So here it is, and so the disturbance center is right where you'd think it would be from the 850 millibar analysis over the border of Kansas and Nebraska. And the cloud head is extensive and fairly impressive looking, going all the way to the western border of the Dakotas, southern Manitoba, and then beginning, as you can see, over this 6-hour period, spreading from high clouds to more consistent mid-level and thicker clouds. And that's what we're in for that the rest of the day. And then a fairly sharp cloud boundary to the west. There was, at least in the dew point map that I saw this morning, we'll look at the surface off in a minute, a really striking dry line over West Texas. Okay, so that sets the stage for looking at a little bit more in the radar reflectivity. Before we do though, let's look at the surface map. We'll take the big one there, thanks. Okay, so let's go further to the south and over Texas. See if we can't see this dry line. So 69-degree dew point in Dallas, 68 to the south, 69, 71, 70, 70, 70, 28 at is that Del Rio? I think that's Del Rio, right? And then 43, 57, it's 32 at Lubbock. So the dry line is somewhere in this vicinity. And in fact, it ought to also show up as a wind direction change. And so we've got all south-southeasterlies, including this station here. This is a westerly where the dew point's gone to 43. Some southwesterlies, southerlies. I guess I'd probably put it right about there as the beginning of this dry line, right in there. And it is not currently a location where things are developing convectively, and it may not be in this particular scenario. There's a thunderstorm to the east, well to the east, in the moist air, but not along the dry line. But it is a pretty dramatic dry line. And I've always had a dream to drive through it with convective activity to the east. People have told me you get an unblemished view of the thunderstorms because there's absolutely nothing in the air to distract from that. And there's no refraction, there's nothing because the dew point's so low. So I've never done that. Someday maybe I will, but it hasn't happened yet. Widespread dew points in the high 50s and low 60s. Now we can scroll a little bit further north, Pete. Even St. Louis 54, but look we're in the mid 30s here. And so remember we saw that boundary at the 850 millibar level of the strong and high dew point depressions to the north and east of this boundary, and then the lower ones to the south and west. And that's roughly the same as at the surface. Big 10 or more degree dew point differences between southern Wisconsin, northern Illinois, and the St. Louis area. It's actually more like 20 degrees. So, and then when you go further south, you're into the 60s and 70s. So the dew point gradient right about at this location is fairly substantial. And that's where some of the precipitation has made its most far northward progress. Rockford has a light shower right now with a 20-degree dew point depression. So, and the same is true near, is that Rochester or La Crosse? So, right in that region. Okay, can we take a look at the radar reflectivity? So here it is, and this is the kind of rough location of that boundary. It's moved further to the north and east with these reflectivities, with the echoes. It's hard to, Romeoville's down here, and so I imagine that's a station. So these are probably pretty close to the ground reflectivities in this part of the mosaic. So I suspect we didn't see it widespread in the observations, but probably rain encroaching on the Chicago suburbs, on the western suburbs. We certainly saw some at Rockford and right up here in La Crosse, and that's kind of a weaker spot for it. So gradual increase in the likelihood of precipitation. This thing is not terribly well organized. One looks at the cloud structure in the satellite and wonders why does it look less structured here. I think it's probably because the frontal structure is not so strong. That didn't jump off the map at 850. But the largest portion of organized precipitation is the closest one to us. I think it's a little bit more disorganized to the south and west. And then this is all in the cloud head to the northwest of the cyclone center, which again is right about there. And then in the air where I think it's probably dry aloft, you're getting a little bit of popcorn convection popping up in here. This is more stratiform, and then convective activity out ahead of whatever kind of boundary there is at the surface, maybe an amalgam of a lee-side trough and a cold front. So that's the feature of interest. Let's take a look, if we could, Pete, at the West Coast satellite image.
You want visible or?
Can we get the gray and white infrared? I don't think we'll see too much invisible in the central part of the Pacific. Not that it's particularly interesting right now. Thanks. Because the thing of interest is right here. This is the developing disturbance with it. Look at how fast these cloud features are moving to the south and east. So they're carried by that 145-ish knot jet that's on the western side of this beginning to develop upper trough. But look at, there's already reflection in the cloudiness associated with the presence of that upper feature in the northwesterly flow. So this becomes the feature, I think, that we worry about for Sunday into Monday, and organizing the barochronicity back here and kind of getting a nice cold frontal passage for us late Saturday night. I may have the timing wrong, but this is at least event number 2 of a double-barreled activity over the weekend, it looks like. And it's beginning finally to take shape. So, you know, Eric, this is kind of what we were talking about the other day. Some of the jet-like features aloft were there, but there was no really obvious trough. And it gets to be more and more obvious as we converge to Friday morning. And then once it becomes, you know, something you can actually see on the 500 millibar map, it's no surprise you start to see the clouds blossoming downstream. So these numerical forecast models are incredibly accurate. They're just great when you think about what they're doing. They're taking no discernible disturbance and turning it into something on time that is discernible in the forecast and in the observations. So that's, I guess, the overview that I have for you today. Patrick, do you have anything to say about the forecast?
Yeah.
Okay. Okay, then I'll turn it over to you. Thanks. Thank you, Pete.
Could I start with weather.gov, please? And then I'll go back to these. So I'm going to touch on the severe weather / flooding potential for most of the country, which we'll see. So first I want to highlight, this is a map of all the current watches, warning, outlooks. This yellow is a tornado watch for Texas. There's even a tornado warning, severe thunderstorm warning north of that. I'm not really sure where that is in Texas. There's been a couple severe warnings in Nebraska and in Iowa. We have flood watches for much of Oklahoma, flash flood warnings near Joplin. And then where it's dry, you have red flag warnings. So we can expect, as this evolution of this system and then the next one, you'll see a sort of rainbow mosaic of all the watches and warnings come up on this map specifically. It gives a good picture of everything going on. And there's even some wind advisories in Kansas. It's always windy in Kansas, but you know, it has to be exceptionally windy for there to be a noted advisory for those. And so could we go to at the bottom, the QPF and the current outlook maps. And QPF, this is the quantitative precipitation forecast. It's measuring all liquid rain that's forecast over a 24-hour period. This is starting tonight and going into Sunday. And so you'll see, you can kind of make out the overall synoptic picture from just the precip here. You can see there's some sort of, you know, cyclonic curvature to the rain, maybe even picking up individual storm tracks. But largely you can see a wide swath of precipitation from Texas all the way through our region and into Canada with this passing cyclone. Cyclone number 1, I'll mention. You can see areas, you know, get up into maybe close to 2 inches of rain. Definitely where the flash flood watch was in Oklahoma, there's rain, even into Missouri where there's already flood warnings going on. This is just tonight into tomorrow evening. Let's go to day 2, please. You'll see, that's a little weird. This almost looks like the exact same picture. Obviously the values are different, but you can see the same regions are under the gun for rain. Specifically Oklahoma, this is probably what's prompting that flash flood watch over where they don't need any more rain. It's going to be, you know, upwards of 5 inches of rain in 24 hours. And this is over a large region. I'm not sure if this is picking up on thunderstorms specifically, but you know, you get one thunderstorm that sits over your area and you can easily get 5 inches of rain. So to see a large region highlighted with, you know, 5 inches of rain is pretty substantial. Our area, we're in this like 1 to 2 inch rainfall for tomorrow, going into the evening. Then if we go to day 3, you'll see, you know, it's shifted a little to the west, but largely same regions under the gun for severe or for precipitation from these forecasts all the way into Monday evening, it looks like. And if we go to day 1 through 3, this will highlight, you know, sort of what I was pointing out. So individual areas of heavy rain are forecast with these systems. And so we're going to take a look at why is this, you know, this persistent feature. You can still make out that cyclonic curvature to the rainfall. Why does it keep propagating over the same regions? It seems like it doesn't even move between a couple days here. And we get out of it, maybe 2 inches of rain. So this weekend kind of looks like, even though it's going to be warm, it'll be rainy. So I hope everyone got out yesterday because it was a beautiful day yesterday. Okay, and I want to quickly go to the drought monitor, and I'll just look at the overall drought. If we just go to current. Here we go, perfect. So we saw the regions where we're expecting heavy rainfall are not necessarily in a drought. And so that's most likely why there's going to be those flash flooding risks, because the soil is already wet. It's already rained here. We saw that in the the radar, that there already has been rain over these regions, and you put another 5 inches of rain on top of where it's already rained, you're going to have flooding. Particularly in Oklahoma is where they have it mentioned, but I wouldn't be surprised if flooding encroaches on our region. Then on the opposite, in Iowa, where you also have 2 inches of rain forecast, the soil is dry. So you don't expect, you set rain on top of dry soil, all that rain is just going to wash away. It's not necessarily going to seep into the ground nicely. So there's also flooding potential for the exact opposite reason, where it's too dry, the soil is not going to immediately absorb the rain, versus where the soil is going to absorb the rain, but it doesn't need the rain anywhere, so there's going to be nowhere for it to go. So these systems, my point is, they're going to be highly impactful, not just from severe weather, but from just a rainfall perspective, and then continuous rounds of thunderstorms and rain disrupt anywhere from travel to just outdoor plans for anywhere in most of the central part of the United States for this weekend here. Okay. Now we'll go into why these systems are going to be moving the way they do. So if we could go to our own forecast page, please. And I'm going to use the NAM model here, just because it will give us a good picture of just the United States here. And it's a little more clean. So first I want to go to 12 hours at around jet level. So here's a look at the jet stream tonight, Saturday at 0Z. So we see two features. One, here's that system that's bringing our rain for today. It doesn't look like much, but there still is a little jet streak appearing over Iowa into Missouri. So you can imagine on the exit side of this jet stream, we still have rising air, rising synoptic motion, into where the heights are already low, and then sinking air, sinking motion where the heights are already high. So there still is a decent circulation in the synoptic scale right over our region from just this little jet streak. But the most obvious feature is this. Here's our next weather maker. We saw the hints of that in the current satellite picture and upper level charts, but you can see it's much elongated. We have it cuts off right at the base of the trough. We still have that same circulation going on, so you still have rising motion over Arizona where the heights are already low and sinking where the heights are high. So you can expect this feature to continue to deepen along with this feature, but this is obviously more robust in just this look here.
Yeah, and we got a hint with the observations that roughly the same, 12 hours before, that there's cold advection along the core of the jet too, so that's probably digging a trench in the tropopause.
Exactly.
Yeah, really nice setup.
So even though we're seeing significant weather from just this little jet feature here, you can imagine just from this view, this might be the particularly interesting event, more substantial weather, more wide-scale substantial weather, just because of how much stronger it is at the jet level here. And so let's go to 500 at the same time. This is tonight again. We see two trough features emerge. First, here's the first system. It's, maybe there's some hints that it's an old trough feature. There's not too much of a nice trough and ridge couplet, but there is local minimum and geopotential heights. We are on the downstream edge of that minimum and geopotential heights, so we can expect upper level divergence out ahead of that trough axis, which it's kind of hard to make out, but maybe it goes from North Dakota down into Arkansas here. And then here's another trough feature, much more stretched out than this little feature over the northern plains, but you still have, you have a nice vorticity gradient along it, especially out ahead of it, and you have a trough and ridge feature beginning to develop with that system as well as this one. So they look different in the upper levels, but these are producing, almost the same regions of precipitation as we saw in the QPF for consecutive days now here. And then if we go to 850 at the same time, this is still tonight, we can see here's our strong warm air advection. Looks like temperatures are going to rapidly climb from the 50s into maybe 60s and 70s. Overnight, this is in the late afternoon, but you can see this flow is coming straight off the Gulf of Mexico. And it's largely interrupted. So this is all warm, moist air straight from the Gulf of Mexico. Dew points are going to rise as well as the temperatures. And we're in this nice region where we get substantial warm air advection, substantial warming. While it's maybe raining tonight, but especially before the next feature, and you can see ahead of that feature that was sitting well over California, you can see a lot of warm air, primed for the development of more severe weather and more rainfall over the regions where it does not need it. And if we go to the surface now.
Just one other comment here, it never occurred to me, but when you have that upper vortex structure, the shear line on the coast of California and southern Arizona, as it is, the air column presumably over southern New Mexico is poorly stratified at this time because it's so warm at 850.
Right.
One imagines it's almost well mixed to who knows how deep.
Oh, absolutely.
So if you've got strong, forcing for ascent, there's no resistance to the ascent in that location, and you can really spin something up quickly, start bringing water vapor off the western Gulf of Mexico into the Great Plains.
Exactly right. Yep. And this is one of the only locations in the world where you have a nice, very warm, very dry region right next to the Gulf of Mexico.
Yeah.
And so we are lucky / cursed with this happens regularly over our region. We have to be wary of tornadoes, but we get jobs out of it. So that's always nice.
It's a trade-off.
Yeah, it's a trade-off, exactly. So if we go to the surface at this time here, complete the view. Here we have, our system has not moved as much from where it is over southern Nebraska. It's just moved to northeast Nebraska. We are under the gun for some precipitation from this look, a bullseye precipitation right over us. And then you can make out along the developing cold front, maybe dry line, that there's a region of also convective precipitation, especially down into Oklahoma and Texas. And you can make out too, we saw the warm, moist advection at 850. You can also infer it from the surface. High pressure off the east coast, low pressure to our west. And so in the middle, you have clockwise flow around a high, counterclockwise flow around a low. We get flow straight from the Gulf. And you can make out the warm advection as well as if we take these isobars as proxies for the geostrophic wind, we are pushing these higher thicknesses straight to the north. And this continues all the way past the border of Canada until it runs into something else over Hudson Bay. And so a large region of the country will be experiencing this warm, moist advection out ahead of this system and then out ahead of the system that's brewing over the Four Corners at the same time.
Yeah, and just look at how confused it is over the Four Corners area.
Yeah,
in terms of where is the sea level pressure minimum, and it's not put together yet. And,
No.
But there's a little bit of a lee side, at least thickness trough right there. Yeah, 994 and then straight
warming.
southward. Yep.
Yeah,
So there's all sorts of ingredients that are just ready to get organized by that thing.
exactly right. And it's right on the back edge. Places are going to have thunderstorms and then say, oh great, we have a break, and then here comes the next thing right afterwards. And then if we could also look at the lifted index and relative humidity at the same time, please. This will show you the convective availability in a synoptic scale. So here we're looking at, this is the average relative humidity from 850 to 500, so lower troposphere is in the color shading. Anywhere it's blue towards the light blue is where you have moist conditions throughout a layer. The contours are showing you the lifted index. So that's the measure of, at 500, if you were to lift a parcel, is it going to be warmer? Is the environment going to be warmer or colder than that parcel? So anywhere it's negative, the parcel is warmer than the environment. So it's essentially convective lift, free lift. So you can see a large region where it's very moist, right where we had that moisture transport, and it's also convectively unstable. Lifted indices near 12. So that's a 12-degree-Celsius difference between a parcel and the environment. You can imagine you get a thunderstorm, you get some sort of lift, that parcel's just going to take off and produce a lot of heavy precipitation among potentially tornadoes, severe wind, hail, and you can make out the dry line too as well. the boundary between where it's really moist throughout the depth and where it's not at all moist throughout that same depth here. You can also kind of see the rotation around that cyclonic low that's sitting over Nebraska at the same time here. So a large region where it's very convectively unstable and moist at the exact same time. So let's do the same thing and let's go 24 hours in the forecast. We'll start at 300 at 36 hours. So this is the next feature. You can see a much different picture from just 24 hours before. We kind of had, if you ignore this green here, we just had a long extension of the jet stream. It was trying to dig out a trough. It wasn't really doing it. Now we have, here's our nice trough feature with a jet streak on its southern edge and into its eastern edge. Out ahead of it, a lot of diffluence over much of the areas where we saw the rain just 24 hours before, and a nice trough that's at upper levels has developed over New Mexico at the same time. The wind speeds have weakened as that jet streak moved around the base of the trough and into the downstream side as well. We could go to 500 now. So remember, our trough was sitting over New Mexico. Now our trough is centered over Colorado. We have a nice vorticity strip. A lot of gradients in vorticity from the Four Corners region into the desert southwest and then out into the central plains. So you can kind of see we're sort of focusing our severe weather potential, synoptic scale lift potential over the central plains. Just from this look here, with emphasis on maybe Kansas down to the Panhandle of Texas. If we go to 850 now, let's see, look. Here we have, substantial warm advection, more moist flow off the Gulf going straight into where we had that upper level divergence. Interesting that the feature, the trough that moved over us is going to move over us today and remain a disturbance is sort of its trailing cold front is maybe going to be, impacting us. But we're going to be in sort of this where we're under the influence of the cold front. We're also under the influence of continuous southerly flow. So we might have precipitation, it looks like tomorrow, from the interaction of the cold front of the system in Canada and then a warm front of the system developing over Kansas, rather than being directly impacted by the frontal structure from this system that's developing over Kansas. And it'll make more sense in the surface plot as well, but you can kind of make out here's the cold front, and then right on its southern edges there's also a developing warm front as well, and we're sort of in the middle of that.
But you're right. I think in the middle, though, we're still beneficiary of confluence across that temperature contrast.
Absolutely.
I can see two
Yeah.
yellow arrows, one near the nose in Iowa, one east of La Crosse.
Absolutely,
They're confluent.
yeah.
So and we're on the warm side of that, so that's going to be strongly forced as well.
Absolutely.
Even more strongly forced in Nebraska and Iowa, but we don't have anything to shake a stick at. That looks pretty good.
Exactly right, yes. If we go to the surface, at 36 hours now. So here we have our exiting low pressure system. It is weakened, broad precipitation along it. You can make out here's that maybe a cold front extending in the thicknesses down towards the developing system. Maybe there's some precipitation developing along it, maybe there's not. Some of the convective models have precipitation along that frontal feature. The NAM has some developing out ahead of it, but the main feature is here's a 995 low in Kansas, and you have substantial rainfall just from this look, where you have that moist flow running into the upper level divergence, and then you have frontal features beginning to develop with the system. A lot of mechanisms for lift, and they're all sort of converging right from southern Nebraska down to Kansas and Oklahoma and Texas.
Yeah, that's a lot less interesting for us than I thought it was going to be.
Yes.
I'm really kind of surprised. And even over Iowa and parts of, Omaha, doesn't look like it's really under the gun. And I wouldn't think that was the case based on what we just saw.
Exactly right.
Really intriguing.
Maybe look at 42 hours, though. This might be before things really kick in.
Yeah, maybe so.
That's
It
right,
could
yeah.
be
Plus it's the
adjacent
NAM.
time.
NAM is not the greatest model.
Yeah.
It looks so nice, though.
No, I'm glad. No, Patrick, it's a really good point. It
Yeah.
is easier to make a diagnostic discussion, but in the end, maybe it would be interesting to see a higher resolution. And I appreciate what you did. I think that's the right way to go too.
Absolutely.
Why does that precip area up there look like Lake Superior?
Yeah, it looks exactly like it.
It's like a dead rectangle.
Looks just like it.
I mean, it's, there's no physical reason for it. It's just weird.
But the one thing to note is we still have a high pressure off the east coast, low pressure to our west, and so we're still under the southerly moist flow. And so even though it's raining, it looks like over the weekend, potentially multiple rounds of rain and storms will still be, around 70 with high dew points. It'll kind of feel like tropical precip for our region. We really haven't had any moisture this year. This is the first time we're sort of getting a lot of moisture for a long time. So it'll feel like summer, even if you can't enjoy it outside.
Has something happened to the stability? Can we look at that chart
Yeah.
at this time? Because that'd be interesting to see. I think it's going to be still poorly stratified.
It's still-
Yeah,
yeah.
it sure looks like it.
Yep.
I mean, it's exactly where you'd expect the stratification. If all that warm, moist air is running into a wall, either the
Yep.
warm front over Nebraska and Iowa or the trailing cold front from the storm at the southern end of Hudson Bay.
Yeah, you
So,
can make really nice
yeah, I'm confused. We got to see a higher resolution
I want
answer
to
to
look at
that.
42 hours at the surface.
I know the,
Yeah, it goes a little bit.
okay, so
Things-
maybe it just takes a while to develop.
Things
but
start to go.
We definitely have a couple days in a row precipitation chances.
That does look more like what one might expect, yeah.
Right. Not sure if any of this is going to be severe at this time. I know we're in, risk for severe weather right along where the system connects its warm front to the cold front in Canada, and we can maybe look at that at the very end. But severe potential is kind of unclear at this time. And I'm not an expert in severe weather by any means, but it looks like it's going to be just thunderstorms for our region at this time. Main severe weather down into the central and southern plains here. And if we go, I'll just show 60 hours, and we can just show 500. So as the system slowly moves. This is the same trough feature that was sitting over Colorado, and so in 24 hours, it just moves a couple states. We're still under the gun for maybe some precipitation, as we saw in the QPF, but also we're out ahead of the trough axis, where you expect upper level divergence. Maybe not as strong as it previously had been, but there still is upper level divergence where you have this flow going from a trough to a ridge. So maybe there's still potential for some convective storms. We can look at that, but maybe just some precipitation, just stratiform precipitation for us. Going into Sunday, if we look at the surface at the same time, okay, maybe it's a little too, maybe we get some precipitation, but it looks like a lot of it is focused up the northern part of our state and then into Minnesota and the Dakotas from this time. And the system weakens to 1,000 hectopascal low. Maybe some more storms, the same bullseye of Oklahoma and into Missouri, same bullseye of precipitation as well. As the system, slowly moves off into the northeast. And then if we end,
It's a
we go back
mosquito
to the-
storm. It's going to fill up all those lakes
Yeah.
in Minnesota,
Yeah.
and then the state bird will flourish about a month from now.
Exactly. If we could end at the Weather Prediction Center, and if we go back one click, I'll just show you what I was talking about with the severe risk. Maybe one more. So to get to the home page. There we go. If we go to severe weather, first there's areas to our west that are under the gun. If we go to Saturday, here's what I was talking about with, you have the bullseye from Nebraska down into the Central Plains, but along where that cold front connects in the warm front, we're, slight risk. I don't know if these mean anything to you. That's good. Weak tornado risk at this time, weak wind risk, weak hail risk, especially for our region, comparatively so. From the synoptic sense, we'll get a lot of rain out of these next couple days, but severe weather still looks up in the air. And this is just a general thunderstorm risk going into Monday here. So is there anything anybody wants to see that I didn't show, or any questions?
I just have a quick comment. It's interesting because the past couple days, the enhanced risk has shifted back to the southwest, but the slight marginal risk has extended. So it was normally like a much tighter ball kind of in that southwestern part of our state, but enhanced went way back down southwest, but slightly extended farther out. So it's kind of interesting.
Yeah. Oh, go ahead, Patrick.
I was just gonna say, I wonder if that's a function of you have a definite synoptic scale feature with that low pressure system, so you're for sure gonna have thunderstorms focused more to the southern edge of this, and then you had just a broad region of where you have unstable air and it's warm and moist, so maybe that might be a function of you see that expanse of the slight and marginal versus there's gonna be a bullseye of pretty strong storms down.
Right.
Yeah, that's exactly what I was gonna say, that you just diagnosed it beautifully with the walk through the maps, that's what's happened. The structure of the cyclone in Ontario and Quebec has a feature that cuts across the state and gets ingested into the one that's developing in Nebraska, and so
Right.
that's all tied into the way these features have evolved in terms of the risks. Yeah,
Right.
that's how I look at it too.
And these are also drawn by people, so maybe one
And
person to
those
the next
people
steps
don't
in
get
bias.
paid by Canada, so they,
No, they don't.
so the
Yeah.
boundaries stop in the middle of the lakes.
Yeah. No more severe thunderstorms.
It's like, oh, we can't go further.
Yep.
Yeah.
All right.
All right, thank you, Patrick. Thank you, Pete.